Hi everyone, my name is Dattraj. Today's talk will be on responsible data science research. Thanks for having me at VLDB 2020. A little bit about me, I lead the AI research team at Persistent. I've been with Persistent for 3 years and before that 19 years at General Electric. I'm also the author of the book Keras to Kubernetes, Journey of a Machine Learning Model to Production. So that's my LinkedIn profile. So I'd love to connect with you on LinkedIn, answer any questions related to this talk. So let's start. Here, I'll talk more about first of all, why do we need responsible data science? What are the pillars of responsible artificial intelligence? And then I'll get into details of things like standardization, reproducibility, transparency, fairness, and privacy and security. So this will be a 15-minute talk, and may not have time for questions, but we can definitely connect offline for any questions. So first, why do we need responsible AI or responsible data science? The primary reason will be around ethics and privacy. We know that data is the new oil, AI is the new electricity, and AI is touching all aspects of our lives. Interestingly, as an example, I think recent cover of Cosmopolitan, which was entirely generated by the DALI model, is a prime example how AI is everywhere. But like Uncle Ben from Spider-Man says, with great power comes great responsibility. So we also see these headlines like Meta had a big problem of data privacy, of how they were using users' data. There were cases where algorithms were biased, especially important algorithms which would predict the amount of credit line for customers. And then Amazon had a lot of issues with facial recognition. So this basically makes it a very important for us as data scientists to have a responsible way of building these data science pipelines, not just the ML model, but right from data collection, data processing to building the ML model, deploying it, and monitoring this model. We need to consider these different aspects of responsible AI, which uh, which I'll talk in this subsequent slides. And this becomes very important when you're putting models into production. A case study around this would be the recent Apple Card example. This was when Apple partnered with Goldman Sachs and they released this Apple Card, but they found out that the algorithm that was giving credit lines was actually biased, and it would treat uh, it was biased on gender. And Steve Wozniak himself tweeted that he got a 10 times bigger credit limit than his wife, though all the other parameters were same. So this was the case where the algorithm didn't see gender, but ultimately because of the features were correlated, uh, gender played a role in making the decision. Then another reason for responsible data science would be also the hidden technical depth. This is a famous paper from Google. It's and many MLOps tutorials actually have this diagram listed on their sites. Basically, what it says is that the ML code development becomes very limited. It's a today there are standard libraries, low code libraries available. So you don't really data scientist doesn't really spend a lot of time in the actual algorithm, but a lot of time is spent in configuration, feature extraction, serving, and other aspects. So you want to standardize these things. You don't want to build these things for every ML project. You want to have some platforms or reusable patterns to take care of these things, and you want to be have this standardized. So this will make your time the development also small because you don't need to reinvent the wheel. Plus, these are established patterns which can be reused and which are proven to be production grade rather than you building a one-off solution for something like this. So this is the second reason you want to reduce the level of technical depth that you're building over time, especially when deploying ML systems. So in a nutshell, we would say responsible AI, if you look at these different concerns, we can summarize it into these five pillars. This needs to be accountable, so you need to have way to audit your ML model development, data analysis, do an error analysis, do a fairness and bias checks, bring the human in the loop at the right time. It needs to be your ML development cycle or data science pipeline needs to be reproducible. You have to have that level of standardization, either using a data catalog, model registry, maybe an ML ops pipeline, a CI/CD process for ML, which is becoming very popular today. And if you are doing a lot of ML development, that's almost a necessity today to manage the bulk of ML development. Transparency becomes very important. You want to be have models that are explainable and even more so inherently explainable or interpretable. Interpretability is basically a model that you understand the inner workings and you are actually interpreting it rather than just having a proxy model that explains the results of the model using some feature perturbation, etc. And then once the model is deployed, one very important thing to consider is the model is not stationary. It's a living and breathing thing. Over time, the data changes, the relationships between the features changes. So you want to be able to monitor for data and concept drift and have a mechanism in place to resample the data and redeploy your ML model to production. And two things that often get overlooked is security and privacy. Security is very important because today, especially when you release a model in public, there can be any sorts of inputs that the model will face. So adversarial testing becomes very important. In some cases, you may want to run it in a confidential computing environment like a TE or a secure enclave. And then privacy is very important in today's world. You see this, the examples that we showed. Uh, you want to be able to, with regulations like GDPR, you want to be able to control the level of amount of data you collect, minimize the amount of data you collect, and justify why you need that data, and make sure that data is used only for the required reasons and then deleted. So the concepts like federated learning, differential privacy help you measuring the privacy and keep building a privacy aware machine learning. So in a nutshell, these are the five pillars. So let's dig deep and talk about a few of these things. So number one will be standardization and reproducibility. This is very popular and most companies are looking for this as an automated way of building ML models. And as we saw, model development is not just about the algorithm. There are many things involved in it, right from data management, model development, production deployment, and model lifecycle management. And like I said earlier, there are many patterns that are available. You should seriously be aware of these patterns as a data scientist and leverage the pattern as needed in your ML development cycle. So something like a data ops pipeline for a data management, or when you're using data building training data, you recommendation is to have a version data catalog. So when you say your model is getting 95% accuracy, it's on this version of the data in a catalog data. Data quality is very important. You want to make sure you understand the completeness and the quality aspects of the data. For model development, AutoML is becoming very popular for trying out different combinations, hyperparameter tuning, and you need to have the right metrics and explanations for your ML model. For production deployment, serving infrastructure is highly recommended, especially something that can support A/B testing, because you don't want to just wait for a model and then collect. You want to test multiple models. And today, even multi-arm bandits are being heavily used. It's a concept from reinforcement learning applied for testing different ML models together. So all this should be part of your automated CI/CD pipeline for ML deployment. And then when you look at the life cycle of the ML model, you want to have a model registry. You want to monitor the model, and then have ways to monitor the data. Look at outliers in the data. So if your model is getting too many outliers, you want to be aware of that and make sure that these outliers are handled with. And then drift detection also becomes very important. Both the data drift and the concept drift is very important when you're dealing with ML lifecycle. So these, and then there are a lot of these open source tools that you see at the bottom, like DVC, H2O, MLflow, which can help you with standardizing your process. They have these patterns already captured. Or you could look at hyperscaler like Azure or Amazon or Google, and they also, their platforms capture these patterns. So the actual tool may not be that important. The important thing is to know that these patterns exist, and your data science pipeline should have these patterns for standardization and reproducibility. Next one is about fairness and transparency. So transparency becomes very important. We often hear people talk about, hey, my model is like 97, 98% accurate, but then on what data is it? Is it on the entire training data, or certain cohorts in the data are giving you a lower accuracy? So a model error analysis becomes very important. So this is an example you see on the screen, where you see that the overall model is giving a pretty good accuracy, but then as you drill down to a particular applicant income and a particular area like suburban area, your accuracy drops severely. It becomes like 70%. So you need to be able to identify those cohorts. And today, a very popular pattern is using a model card. A model card should, so every ML model should have a model card, and that should tell you that for certain cohorts there is a bias in the model, and that these cohorts may have a lower accuracy. So it's okay to admit it, at least you are aware of what the model is actually seeing. And then drift detection. This is actually from one of the demos that we had, and you can refer to this article. I had written an article in VentureBeat, which talks about some of these patterns. So you see that before COVID and after COVID, the pattern of data changes. So there's a data drift which could cause your model to change. And then explainability, interpretability becomes very important. This is a global explanations where you look at the entire model on the test data set, try to explain it, and then local becomes an individual loan approval prediction. Can you approve it? So both are very important and very relevant. Let's switch to security and privacy. This is again another very important uh, concept. Security is again around adversarial attacks. So you want this is a famous example where a machine learning computer vision classifier, which was trained to identify fruits like banana, you could just create a sticker, print a sticker, and put it on the table. And just because the sticker was there, the classification would change. So it is easy to fool machine learning models. There are many papers which show these examples. So this could be a trivial case, but imagine if you are a self-driving car and then somebody puts the sticker on the stop sign and you miss the stop sign. That could be a uh, major effect. So adversarial testing becomes important, and like I said, this is easier said than done. You need to consider all your scenarios from the domain side and try to build testing around it. For privacy, federated learning is becoming very popular. Federated learning basically, if you look at the figure in the middle, traditionally you combine data, diverse data in a central place and train your ML model. Federated learning is a decentralized way of training ML models by keeping data privacy in mind. So your data remains on the individual machine. So assume these are three companies. This could be three hospitals or three healthcare providers having sensitive patient data. Now, the data remains on their machine. You train a local model on each of them and send the model updates, the weights of the model, to a central federation server. And federation server does aggregation. It could be a simple averaging or it could be a weighted averaging. But the magic is happening at the federation where all these weights are combined, and then the aggregate model is sent centrally back. So you don't send any data, but you send the model weights, and these weights, the training happens centrally in a decentralized manner, and you send the trained model back to this individual nodes, and we see that the insights that are gained by the global model actually it captures insights from the local model. So even if company C has very less data, its local model may give you like a 50-60% accuracy, but because of federation, that accuracy starts raising to 90% because it is learning from insights from all the models. So this is a very popular pattern in machine learning, federated learning, which can help you build really popular ML models. Aside from federated learning, there are other aspects of privacy. Anonymization of data becomes important, but anonymization often has a lot of drawbacks because it's easy to you either lose data or you it's easy to trace back data. Some other aspects are like differential privacy, where you add controlled noise to the data. So the aggregate results still are valid, but your individual presence or absence of an individual doesn't really affect in the model. So this is around privacy, and regulations like GDPR mandate you having some level of privacy in your machine learning lifecycle. So it's very important that you have these patterns like federated learning, differential privacy to in your ML lifecycle. And finally, these are some of the references that we have. I just had 15 minutes for this talk, but then you can look at some of these videos that we have made available and some of these articles that we have published. Responsible AI is a major initiative for us at Persistent, and we help our customers in healthcare banking domain try to standardize their ML process and introduce some of these concepts around privacy, fairness, bias into these life cycles. And we typically, our AI research lab publishes a lot of this material, some of which you are seeing on the screen. So we would love to connect with you, have a chat with you, and if there are any questions, we can definitely answer offline. So thank you. Thanks for your time. Bye.